Okay, so let's get started. We're going to be taking a look at understanding the fundamentals and the basics of a turbocharged system, specifically related to boost control. So we need to break down in this tutorial what a turbocharger represents, what a wastegate represents, and then a boost control solenoid, how that fits into our control routine here. We'll also be talking about some fundamentals within the boost control programming, such as understanding duty cycle and frequency. Now we're getting all of the basics, the fundamentals out of the way in this tutorial so that as we move forward into future tutorials talking about open loop style boost control, closed loop style boost control, dome pressure style boost control, things will be more relevant, make a lot more sense because we have the fundamentals out of the way. Okay, so let's jump in here. Right off the bat, we're going to be talking about a turbocharger, understanding the different parts of a turbocharger and how they fit into our turbocharged system and ultimately into the boost control routine. So looking at this turbocharger, this is going to be a cutaway of a turbo. This is pretty much any turbo you're going to be looking at. It's going to have a compressor wheel and a turbine wheel, and they're linked on a common shaft. We also have a compressor cover and a turbine housing. The turbine housing connects to our exhaust manifold that's fitted to our engine. So all the exhaust gas is going to go through the turbine housing, which is going to spin the turbine wheel faster as we have more exhaust mass flow or exhaust gas going through the turbine housing and across the turbine wheel. Now, because they're linked on a common shaft, as the turbine wheel's speed increases, we'll find that the compressor wheel speed increases. As we spin the compressor wheel faster, we're going to generate more pressure, boost pressure, and more compressed airflow coming into the engine. So we increase the airflow, we increase the boost pressure as the compressor speed increases. Now, going and taking a look here at a typical aftermarket turbo setup, we're going to find we have a couple different components here. So we have a turbo manifold, exhaust manifold, that's going to connect the exhaust ports to the turbine housing. Then we have our actual turbocharger. In this particular picture, we find we have a downpipe that's connected to the turbine housing. So any of the exhaust gas, as it's spun the turbine wheel, it's going to discharge to the turbine housing, go through the downpipe, and then go through the exhaust and be expelled out into the atmosphere. We also have in this picture an external wastegate. We'll be talking about internal, external wastegates here in just a few seconds. But we'll find that this is going to be typically what you can expect for components within the exhaust system on a turbocharged engine. Now, let's start to expand on this a little bit. Let's talk about internal versus external wastegates, because what we're controlling when we're talking about boost control is controlling either an internal or an external wastegate. So looking here at our first example, this is going to be a traditional internal style wastegate. We're going to find that there are a couple components with the internal wastegate. We're going to find we have an actuator, which is composed of our little top hat and the nipple that's on that gets a pressure reference. Then we have a connecting rod that's going to go between the actuator, and we can see it's going to be connected to a flapper valve. That's going to be found on our turbine housing. So the flapper valve and the internal wastegate, something that we typically can't see, the downpipe is going to be covering it. But what's going to happen is we are going to open that flapper valve, which will bypass some of the exhaust flow and exhaust pressure, bypassing it from the turbine wheel and letting it go right through the downpipe and the exhaust. Now we do that to be able to regulate that shaft speed that the turbocharger is spinning at. We don't want the compressor, let's say, going faster than 50,000 RPM. The only way we can regulate the amount of shaft speed and compressor speed to regulate the boost pressure and the flow that's coming into the engine is to regulate the exhaust pressure and exhaust flow. So we do this using an internal or an external wastegate. So in this example, what we don't see is a flapper valve or a flapper door that opens up. That's going to be essentially dumping out excess pressure and excess flow coming from the engine to make sure that we're keeping the shaft speed regulated at a certain RPM or a certain speed. So taking a look at this here, the next picture, this is what we are working with in virtual programming within the link with a boost control solenoid. So on our previous picture, we had a little wastegate actuator hat, and then there was a nipple found on the wastegate actuator hat that typically gets a boost pressure reference. So we usually go and connect that little nipple to a pressure source, whether it's on the charge pipe or the compressor cover. And if the wastegate actuator is rated at 10 pounds and we're giving it a boost reference, it will open up that wastegate actuator and regulate us to 10 pounds of compressed manifold pressure. So even though the exhaust pressure isn't directly connected to the manifold pressure, the boost pressure that we can measure coming into the intake manifold, the wastegate actuator does a pretty good job of regulating to wherever we want to be at. In that situation, if we just simply remove the line that's going to the wastegate nipple, it'll allow us to build maximum boost pressure. So whatever the exhaust pressure is going to be generated in the turbine housing, there's going to be a certain point where it's going to blow open that flapper valve, flapper door, and it's going to start to just naturally bleed off the pressure. But that may be at something like 30 or 40 pounds of boost. So if you have a 10-pound actuator and you just simply remove that pressure reference, that can build whatever the system is allowing itself to build. And that's all going to be hinging upon the exhaust manifold pressure, how high the exhaust pressure gets till it blows open the flapper valve. But it can generate usually 3, 4, 5 times whatever your wastegate actuator is rated at in terms of boost pressure. That's not ideal. So what we want to do is put a boost control solenoid that's going to go between the pressure source and that nipple on the wastegate. And we can see in this orientation right here, we're going to find just that. We have our little nipple off the compressor cover. That's our pressure source. That's going to go into the boost control solenoid, and then we're going to be connecting the other output from the boost control solenoid to that nipple. And what we're going to do is bleed off some of that pressure going to that wastegate nipple, the actuator nipple, in order to get the boost to go up or down. So essentially, we're going to be virtually controlling the solenoid, telling it to open or close a certain amount to regulate how much the flapper valve on that internal wastegate is opening to regulate how much boost pressure we're going to build. So hopefully that makes sense. All right, let's move over here to our next example.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.